Okay. Hi, I'm Diane. I'm Avada Kedavra on like everything. It's the easiest way to find me, if you can remember it. I've been informed that it's very long and very difficult to remember, but I don't really understand why, because it's like Harry Potter killing curse, but with cat. Sorry. It's like a pet peeve of mine. I don't understand why it's so hard to remember. 'Cause I think it's super clever. Alright, so I work for Mozilla, and I work with Rust a lot. And I don't know how many of you have heard of Rust, have used Rust. There are a lot of people who are crazy about Rust. And it's pretty nifty. And you have this idea of safe versus unsafe. So when we talk about Rust safety, basically you're guaranteed type safety and memory safety. I know I've spent some time doing buffer overflows and integer overflows and such. So it's really nice that these are prevented by default in a language. It really limits the sort of undefined behavior that you see. By default, all of these things are prevented. You aren't going to have dangling pointers, data races, integer overflow, and debug builds, buffer overflows, and iterator invalidation. Most of these are done at compile time. Integer and buffer overflow preventions are done at runtime. But we can minimize these by idiomatic Rust uses iterators. So generally speaking, if you have an array, you're not iterating over it with indices. If you do, in safe Rust, you can still overflow your buffer. If you code like a proper little Rustation, then you're not going to, because you're going to use an iterator. So you're not going to overflow because the iterator knows where the end of the buffer is. So unsafe. Like, what does this even mean? There are things that you cannot do in safe Rust. So we have to go and look at what this borrow checker thing is. The borrow checker, when you code in Rust, is both your best friend and your worst enemy. It's always yelling at you. And then you have an argument with it. Turns out, borrow checker's right, you're wrong. 100% of the time, you are never, ever right. So if you have a value and you assign it to a variable x, x owns the value. Now you assign the same value to to y. Now y owns it. It's moved from x to y. If x tries to access the variable that is now owned by y, the compiler will throw a beautiful error. That looks a lot like this. You can borrow a value immutably as many times as you want, but you cannot change it. You can only have one mutable reference at a time. Otherwise, you invalidate all of these safety guarantees that you have in safe Rust. What this does is this prevents dangling pointers. Rust tracks the lifetimes of variables, so instead of garbage collecting, you just make sure that nothing's ever deleted until you're done using it. So like I said, you can't do everything in safe blocks. Sometimes you really have to violate these rules. There's one situation in particular that I'll highlight in like a minute. And the key thing that you can do in unsafe Rust is you can dereference raw pointers. Usually, you do not want to be messing around with raw pointers when you're in safe Rust. Well, you never want to mess around with raw pointers in safe Rust. And generally speaking, as most of us are aware, messing with raw pointers can be a recipe for disaster, right? There's one function in particular, memTransmute, where you just take a pointer and you tell it to be anything you want it to be. And it's extremely terrifying. I was using it once and then I told my boss, I was like, I feel like there's got to be a better way to do this. I really feel like I should not be doing this. He was like, yeah, you're doing something horribly wrong. Anyways, the way that we control it is you denote something as an unsafe function or an unsafe block. You can only call unsafe code from other unsafe code. but you can encapsulate it. So like, if we had a function foo that wanted to call unsafe foo, what you would do is you would have function foo, and then in the unsafe block, you would call unsafe foo. So that way you can encapsulate unsafety within safety. And this is how the standard library handles a lot of this. So you can do tons of things with purely idiomatic safe Rust, including like call C functions, because they'll be wrapped in a safe wrapper. So this is the results of a little program that I wrote on the Rust compiler code. So the Rust compiler is written in Rust, which is always a really great spot to be when you're a language. And what it does is the compiler is composed of different modules. So all of these lines here, these are different modules. And the little numbers that you can't read are the percentage of unsafe functions and unsafe codes, and also the number of panics. So panics are basically, oh no, something's gone horribly wrong, we need to abort runtime immediately. And those can be kind of dangerous when you use them. They aren't going to lead to undefined behavior, but they will, terminate your program unexpectedly. So, shows the amount of unsafe code in all the compiler modules. A lot of them are 0, so that's good. That means that the Rust compiler is theoretically pretty decent Rust code. One problem is a lot of people come to Rust from C, and they're like, iterators? I don't want to use an iterator, just let me write a for loop like I usually do, right? But that's where you get into problems. And if we want to write safer code, not only do we have to use the safe language, we also have to write it safer. So one problem, the worst is, that I saw at a glance 5 minutes ago, was lib collections at 25%. And this makes sense. If you're implementing the collection data structures, you're going to need to use unsafe code. It's just how it is. Anyways, so the way I did this is I just went text line by line. Have you ever used count lines of code? Yeah, I just went line by line and counted the number of unsafe code. This is the worst way possible to do it. But, it gives you a pretty good idea of how safe the code is written. Realistically, you need to create a simplified abstract syntax tree and test your predicates and all these things that programming languages people love to talk about. You can also categorize the unsafe code as, is it FFI? Are you calling it C code, or are you just writing unsafe code? And then borrow checker. I don't know why there aren't more memes about the borrow checker, because it really is your best friend and your worst enemy when you're developing in Rust. So maybe someday I'll have time, get around to this. Ideally, what I'd like to do is look at the Rust ecosystem as a whole, script over all of GitHub, all the people who are trying Rust out, and then ditch it immediately. And then some of the people who stick with it. And see, are Rust programmers coding safe-ish Rust? And, what can we do given these measurements of safety for libraries? Is everyone using some library that's a ton of unsafe space? Which we can view as attack surface, realistically. So anyways, this is my cat, Batman. This is how you find me. I am a Vada Kedavra everywhere. Any questions?
Do you have an overall stack for the compiler? Lines of safe versus unsafe? What percentage of the whole thing?
I mean, I could probably add all of these up, but no, they're broken out by module, and you just go over it. For what it's worth, I really enjoy working with Rust. It's got a bit of a learning curve, but Cargo, the package manager, is fabulous. I love the package manager. So, and that's how I judge languages now. Do I like your package manager or not? Anything else?
You've got the distinction between safety and non-safety. You mentioned looking at FFI code. Is there anything are there any sort of really bad smells that can arise from unsafe code?
So, like, something that you can look at if you are dereferencing raw pointers, or if you are calling the mem transmute function that I mentioned earlier, those should kind of trigger warning signs, like, we really need to make sure that we aren't doing something horribly wrong here. This might be somewhere to dig a little further. So stuff like that, really. And if someone decides, another really bad smell for Rust would be if you iterate over a collection using indices. Indexing. If you don't use an iterator, because that's a really easy way to violate all of the safety guarantees without going into unsafe code.
Is it possible to modify so like with C code you can write Clang modules to find sort of particular unsafe, even non-memory corruption related issues? Is there anything like that for Rust?
So I know, like, there's built-in cargo fuzz.
Okay.
So you can fuzz programs pretty easily. Aside from that, maybe. I don't know.
So in the unsafe mode, there are absolutely no checks whatsoever done on the code, and the broker will be happy for you to do whatever you want there.
No, not necessarily. In unsafe code, it's not like the Wild Wild West. Like, it's not, all holds barred, like, let's just do whatever we want. What it allows are basically these things. So compared to C, the undefined behavior that you can get in unsafe Rust is very limited. You're generally not going to get arbitrary seg faults.
You can call mallocs and stuff like that from C, can you? So
yeah. So I mean, if you go from safe Rust into an unsafe block and you're calling into C code, and that C code does all sorts of ridiculous stuff, yes, then all sorts of ridiculous things could happen in that C code that is being called from Rust. And there is, I'm doing some work to try to figure out, how we can protect ourselves on the Rust side when you're calling into these unsafe blocks and in these unsafe C functions. It turns out that really the only unsafe boundary that you can say, is really secure, like the hard wall, is this module level. So basically just like the project level. Like I work on a browser, and so our idea of modules is, we have the net crate, and we have the style crate, and we have the script crate. So those top level modules, those would be the unsafe boundary. Mm-hmm. So if you did something horrible, it would be contained. Yes, that's the word I'm looking for. It would be contained to that module.
Just to confirm what you said, so am I right in saying that if you call unsafe code within Rust, it can affect the entire application? There's not really
the entire module.
Okay.
It can affect the entire module. The module is not necessarily the entire application. It could be, but it could also be a component.
Okay.
And, Rust is a pretty new language. It hit 1.0 in 2015, so, we're working on trying to figure out what exactly it means to be unsafe and what exactly are the limits of unsafety. It's a cool language. It's fun to work with. It does make your life easier once you get used to dealing with the Mr. Bar checker. Anything else? Alright, sounds good. If you're interested in using Rust, they're on IRC, Rust channel, Rust Beginners channel. Everyone's very helpful. Everyone's very friendly.
Thank you.
Thank you.